Friday afternoon, I'm going to my dermatologist, so I'm having some issues with some skin stuff. So as you get older, your body starts to break down just a little bit, and your house starts to break down maybe. My house is older than I am, though. But so I'll let you guys know about the cracks in my foundation. Hopefully, it's not going to make me go broke. We hope not, but then no. All right, so homework check tomorrow. We do have a lot of our friends absent today, so I'm just going to go ahead and dive in. If you're one of our friends who's absent, sorry, feel better, get better, but don't come back if you're not better. Love you, but we don't want you what you got. All right, so we are going to start to talk about more probability today, except now we're at the fish store. So in 525, we started to talk about systematic lists. So remember our trees that we built last week? Flip back in your notes if you need to check and remind yourself. We built those probability trees. We built probability tables. What was it that made us go from a probability table to a probability tree? What did we say wouldn't work on a table? Alex? Yeah, so come on, you guys. We'll wait a second. I know it's cold. Thank you for getting coats and being flexible. I appreciate that. This is also why when we talk about Felix might not stay here, like 2 or 3 years from now, it's okay. Just so, thank you guys for being understanding. And no one's really been whiny this morning. I've probably been as whiny as anybody. All right, Alex, say again, when can't we use like a probability table like we see here? Yeah, 3 different like options or 3 different choices or 3 different outcomes or anytime we go beyond 2. Our table can go from left to right with one set of options and it can go from top to bottom with another set of options. But once we get beyond that, we had to build trees. So I don't remember the problem that we talked about last week where the tree was really useful, the first probability tree that we did. It was kind of delicious but kind of confusing maybe. Grant?
Isn't it ice cream?
Yeah, pick an ice cream. Right, so you had to pick an ice cream flavor, then toppings, and then mix-ins that made us use a tree instead of a table. Any questions what we did last week, or any crazy questions from the homework? You just like were pulling your hair out or something, and we had that 5 minutes, that would have been time to really do that. Actually, I shouldn't even ask that because tomorrow, let's talk about tomorrow real quick. Because I'm out on Friday, we're going to assess sections 5.1 and 5.2. So if you look at how this chapter is broken up, we've got 5.1s, 5.2s. Today is the end of section 5.2. Then we move into section 5.3, change gears slightly. Friday's assessment will be over the 5.1 and the 5.2. The math journal check, so I'm going to keep your journals over the weekend, will be over 5.1 and 5.2 and your table of contents, make sure that's all good. Tomorrow's kind of going to be like a flex day in a way. We're going to cover any content that we've missed from the chapter. We're going to solve some problems together to prep for the mastery, but we're not going to move forward, and there's not going to be new homework. So, Friday, and actually, now that I'm saying it out loud, I might not do a homework check tomorrow because I'm going to collect your math journals on Friday. Friday, when you turn in your test, you'll turn in your math journal. So, let's make sure we're all on the same page with that. 5.1 through 5.2, all of these homeworks up through 5.26 will be due on Friday. Today's Wednesday, 5.26 will be on Friday anyways. So, if you have any homework questions, please bring those to class tomorrow so we can solve them together and you can have them done for your math journal check. Right? That would make sense. So, Nina's going to buy a new fish. Now, her parents are kind of, really, you want fish? Get a small fish. So she goes and she looks at the tank that has the guppies and the tetras. So, anyone have fish? You own fish? Yeah. See? So, guppies and tetras are little guys. Right, and they're cool colors. So both the guppies and the tetras are broken up into yellow, orange, where are we at? Blue and silver. And there's an equal number of fish of each color in the tank. How they did that, they like took a picture or something and then they counted because it's really hard to count fish while they're swimming. So who knows, but there's an equal number, right? They're just accept that for mathematics. It probably wouldn't happen in the real world. A fish is probably going to eat another fish or something. It wouldn't stay the same number for long. So if Nina scoops out a fish at random, what's the probability it's a silver tetra? So talk with your partner. What do you think if Nina scoops out a one fish at random, what's the probability it's a tetra that is silver? Now be careful, I would not look at the table necessarily yet, because we don't know if that's right or wrong or what's going on. I would only talk with your partner what you guys think. If you didn't head your notes yet, you should do that now.
No, I'll go over there, Grant. Don't worry about it.
It's a cooler area because it's like darker over here. No, 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 and no. We're not throwing books. We could like catapult, and that would be a math
Throwing
problem.
books is less dangerous than throwing rulers at
Yeah.
A book is denser. All right, what do we think? The probability. How do I write probability of something? Let's get cards out. Let's see who's awake today. Kate, how do I write probability of something? So for 76A, because we're all filling out our notes in a very nice fashion, we're going to talk about the probability of. So I'll make it 3 groups here. They just joined up. This is why it's funny, because Liam and Grant were just like, hey, we don't have partners, and everyone else is good, so let's make 3. We're good. I should have a couple 3s around the room. Probability of what goes in the parentheses. What are we looking for? Silver tetra, right? Sorry, as soon as I saw the hand, somebody just said it out loud. So we write silver tetra. Please make sure you're with me. Probability of silver tetra. And any situation, don't give me the numbers for this one. How do I know what's going to go in the parentheses? Give me the words, what we think about. Alex?
You do like, you do the amount over the total.
Yeah, we look at what we're looking for, find how many, that goes in top, total goes in bottom. Now, do we know how many silver tetras there are in the tank? No. Do we know how many total fish are in the tank? No. Crap, so how do we do this? Delaney?
There's 3 groups of different fish, and there's 1 of 15 groups, so wouldn't it be 1
What are your groups?
Like the orange fish, the yellow fish. Oh wait, no, there's 4.
Oh, there's 4. Okay, so there's 4 colors.
Yellow, orange, blue.
Yellow, orange, blue, silver.
So it'd be 4.
So it's 1/4. So silver is just 1. Hold on, don't write that. Is that the only split in the tank?
But there's also 2 different types of fish.
There's also 2 different types of fish. So it's not that there's one. Now, if this was just silver and we didn't care about tetra, then it'd be 1/4. But we do care about which type of fish it is. So we don't just look at the color split. We look at the fact that there's silver tetras and gummies. There's yellow gummies. Yellow tetras and guppies. Blue tetras and guppies. So there's actually 8 types of fish here. Even though we don't, you can write this now. Even though we don't know exactly how many fish there are, because they told us there's equal amounts, we can just say 1 out of 8. Every type has an equal chance. So now Nina sets up this table. And now we can probably relatively trust this because what we just talked about, there's 8 different types of fish. So jot on your paper really quickly, like, doesn't have to be super nice, but let's throw this table in our notes. So make a big old wide rectangle. Up top, we're going to put the color splits, and on the left, we're going to put the fish splits. Now I'm going to make your life easy. We're not writing words. Yellow, orange, blue, silver. What are my fish split? Or what is my fish split? Tetras or guppies, right? T or G? If there's equal amounts of everything, we could give numbers to this and we could quantify it, but we don't really have to. Because we know that a yellow tetra is one of the 8 spaces in my table, so its probability is 1 out of 8. Fill in enough of this table. I mean, I would advise fill in the whole thing, but if you're working slow, fill in enough of this to make sure that you understand how we get the items inside of our table. What does it mean? Well, this is the intersection of an orange fish and a tetra fish. Cam, I got you. I got you. Here, you push that way. So you're copying the table from the book, essentially. I don't need to fill in all of mine because you have it there in the book. So you don't have to do this in your notes. If you want to, you can. But what if, instead of looking at this for the events and what's going to happen, I just look at what I made, like visually, kind of geometrically. See, this kind of looks like a rectangle is broken up into equal parts. And if this was all the same, you got to imagine with me because I'm not very artsy. Sorry, mine doesn't look great. How wide is my rectangle? 4, right? How tall is my rectangle? 2. What would the area of this rectangle be? 8, right? We talked about this last week in a way. How many options are going to end up? No, wait, I see some aha faces back there. What? What's going on? Did you guys already talk about this? Oh, you're just. I'm cold too. If you have any other coats or anything you want to go get it. I'd start a fire if it wasn't too dangerous. So the area of this would be 8. What would be the area of one of these sections? 1, right? Because it'd be 1 by 1. So if everything's equally broken up, we could actually look at this geometrically and just say, oh, my yellow tetra, or whatever I'm looking for, is 1 box out of how many total you have. Now, obviously, every situation won't have 8, so I'm giving you this info to extend it to a different situation. So, if we look at 77, we are going to have a bag of blocks. Right, so check out 77 with your team. I want you guys to just jump into this on your own. I'm going to give you a few minutes to read it, talk about it, write your notes, see what you think. So just jump into 77 on your own. Please don't move on to 78. We'll talk about that one together. what I'm doing on the board. You guys are working on your own. Ignore what I'm doing, please. You do. You just need like clear tape or what? You wrote my book. I also have pencils. Now, I want to do this in a simpler fashion. So, I decided to make the table that I drew up there. So, imagine if this is your partner or sibling or whoever else. Let's say it's not you that drew that table. And you're being asked, is this table correct? Can I use this? Is it allowed? Whatever we want to say. I'm dealing with the fact that a lot of us are still testing. Zoe, what do you think about the table that I drew up there? Give me any feedback. Nice, thanks. It's blue, right? My square is almost a square. Thanks for saying it's nice. I appreciate that. Marvin, what do you think? Does that table work well to represent what we're doing? So let me back up and ask some other questions. So Marvin, in this situation in problem 77, how many blocks are in the bag? 3. Okay. What color? What do we know about the blocks? Okay, so we've got blue blocks and yellow blocks. So my thought was, and again, please don't copy this. My thought was I have 2 things that can happen, right? I draw, I get a blue or a yellow. Second time, and I put the block back, tells me the problem. Second time I draw, I get a blue or a yellow, right? So what? So sure, let's use this table. But according to what this table looks like, what would my probability of drawing a blue and another blue be? You guys aren't writing this down. A 4th, right? It's one of my 4 sections. What is the probability of drawing, let's say, a mixed, like a blue and a yellow, or a yellow or a blue? Like, I don't care which order, just I get one of each. 2 4, so I got a yellow blue and a blue yellow. So like a half, right? Question is that true? What's the probability of drawing a yellow yellow according to the table that I have? A 4th? Do you think my probability of drawing blue back to blue is the same as drawing yellow back to yellow? I need some critical feedback from somebody. Do we think this is accurately showing what we want it to show? Just in case you wrote these down, if you're one of the people that writes down everything, or if you're watching the video, please put those with a question mark. We're not sure of those. Patrick, what do you think?
I don't think it's going to work.
You think it is or is not?
Not going to work.
Okay, why?
Because obviously there's more blue in the bag, and there's only one yellow. So if and you didn't, when you were making your table, you didn't put 2 blue, you only put 1 blue there. And
But I only have 2 possible outcomes, right? Only blue or yellow. You're right. Just defend yourself. I'm pushing you to like.
So, what else train of thought?
Could I figure a way to make a table like this that would work? Like, could I make a table like this work?
Maybe.
Maybe. But I would probably need more.
Yeah.
Right? So like you said, there are 2 blues. I only wrote 1 blue. I would have to somehow mathematically show blue is a better chance. Grant?
I just have a little comment. It's sort of impossible to get 2 yellows, isn't it?
Not impossible. You put the block back. So this is with replacement, is what we've been calling it. So like when you draw a card from a deck, put the card back in the deck. This is with replacement. So we put the block back in. If we kept the block out, you'd be right. It'd be impossible. So let's not use this table right now. If you wrote this down, please like put a giant question mark or a maybe or something. It needs more. Right, Matt? I know it's cold. Try to stay awake. So Nina made this table. Now pause for a moment with me and think, what if we had 3 colors? Instead of 2 blues and a yellow, we had blue, green, yellow. And I did blue, green, yellow, blue, green, yellow. This would make perfect sense to us, right? I have 3 options, 3 options. Doesn't this still make sense, even though we have 2 blues? Those 2 blue blocks, are they the same thing? If we have 2 blocks that are both blue, are they the same thing? I still hear question marks. I have 2 pink TI-84s. Are these the same thing? Are these fit? If I pick up this is the same as this? This gets into that whole like theory side, right? You have a twin. You the same as your twin? No. You're not physically the same thing, right? Just like the heads on the one quarter and the heads on the other quarter could match, but they're not the same result. They're 2 different results. These are not the same thing. They're the same calculator. They're both pink. They're both TI-80, but they're not the same thing, right? Those 2 blue blocks, 1 blue block, Kate's having trouble with this. If I have the 1 blue block, the other one still exists, right? It's a different object. It's a different outcome. So although these are both blues, this might help your brain to say this is blue block 1 and this is blue block 2 because I have 2 blue blocks. This is blue block 1 and that's blue block 2. Not a power. Powers would be up high. This is a subscript. Remember, it's just part of the name. They're 2 different objects. Although they are the same, both blue, both blocks, they're 2 different things. Can we agree on that? I know it's hard to like conceptualize, but they are different. I could just as easily paint the blue one green, one of them, and then literally have 3 different things. Right? I can pull the block out, spray paint it real quick, be done. So, according to this table, I need to scoot it. Sorry, I'm going to erase my 1s and 2s. So if you need to, notate that those are 2 different things. I enjoy knowing what's what. Now, what's my probability of blue-blue? Grant? 4 of my sections have blue-blue matching out of my 9 total sections of the table. What is my probability of a mixed yellow-blue or blue-yellow? Like, we don't care what it is. It's mixed. Alan? 4. Not, ooh, the same. Interesting. And the probability of a matched yellow-yellow. Patrick, go ahead. 1 out of 9. So let's say you were designing a game for Phoenix Fair, and you want to decide on what event the person playing the game wins, and you have to give them a prize or pay them money. What event do you think you would make for the person to win? Yellow, yellow, right? Because it's the hardest to happen. I don't want to pay people out. And actually blue, blue, or not matching are equal probabilities. Those have the same chance of happening because, guys, remember, blue, blue could have just as easily, we could split it, talk about like blue, green, but then think about if that's blue and that's blue. Let's change this to, don't actually do this, but if this was green and that was green, this would be blue, green, this would be blue, green, and this would now actually be green. That would totally change stuff. But if we're only caring about color, these are equal. Getting the same matched blue, getting blue or yellow or blue, and then yellow, yellow. Now, if we care about order, last one we're talking about with this table, if we care about order, what would be the probability of order mattering a blue first and then a yellow second? A blue first and then a yellow second. Patrick?
2 9s.
How do you know?
Because if you look on the chart, it says blue, then yellow on the right side.
Yeah, they made their chart that this was first draw and this was second draw. You can tell by like blue then shows up first, blue then shows up first, yellow shows up second. But yeah, that would be 2 out of 9. And then if I want yellow first and then blue, these 2 out of 9, well, a 2/9 and another 2/9. That's how we get our 4 9s. Questions? So how does this next table make sense? What's his name? I forget. Dude's name. Edwin. So take a moment with your teammate. Look at C. How does Edwin's table make sense for us? Why did they make it the size that they did? Try to match the size of this. Making the BB and the YB bigger boxes. If I want to get, so their table, they said this was draw 1 and this was draw 2. We can always switch around, doesn't make a difference. If I want a blue first, does it matter whether I get the top blue or the like the middle? Does it matter whether I get this or this for my first blue? So why do we really have this split here? Doesn't really need it. If I wanted to get a blue for my second draw, would it matter whether I got that block or that block? No. So why do we have this split here? I don't really know. Can I kind of do that? Well, I should probably erase this split too, right? Because then that's just yellow and blue. If I erase this split too, crap, I didn't want that to be red. Gravity. Oh, so my cardiologist yesterday at my heart appointment, so I wasn't going to be here yesterday, I was down at OSU for heart stuff, like, accidentally, like, threw the clipboard across the room, he, like, went to flip the page, and it just, like, came out of his hands, and I was like, gravity works, and she was like, what'd you just say? I was like, gravity works, it's, like, it's still working, right? He was very confused for a moment. So, this whole section is the same thing, right? This entire region is blue, blue. It was this blue, blue, and this blue, blue, and this blue, blue, and this blue, blue. That doesn't really matter to us. We just put them all together. Both of these were what?
YB. I mean, BY.
BY, right? Blue, yellow. Both of these were Y. We can just start to combine these sections together. So if you compare Nina's table with Edwin's table, all Edwin did was erase lines. He joined up these sections. He joined up all 4 of these. He joined up these sections, and he left that alone. Do we kind of see how Edwin got from Nina's table to his table? Edwin's efficient, right? He's trying to write less, do more. So, Edwin then gave it some numbers, right? There's some numbers here that we didn't have before. Anyone tell me what those numbers are? What they represent? Why he has 2 out of 3 or 1 out of 3 or... I got the same hands I've had up. Alex?
It's representing what it says on the table above. Because 2 out of 3 of the blue, 2 out of 3 of the blocks are blue, and 1 out of 3 are yellow.
Absolutely. These, however you want to jot it, are the chances on the individual draws. You have a 2/3 chance of getting blue when you just reach into the bag. You have a 1/3 chance of getting yellow when you just reach into the bag. So that means if I have a 2/3 chance of blue my first time and a 2/3 chance of blue my second time, this you're going to want to have down. Okay, so please write this with us. That means that probability of blue is the probability of blue the first time plus, not plus, actually times, sorry, forgetting exactly what we're doing. That's first draw, and that's second draw. The probability doesn't change because we put the block back. Right, so we had 2/3 times 2/3. You go straight across the top, straight across the bottom. So, we got that this is 4/9. What about yellow blue? If I took 2/3 times the 1/3. We already know this. We already talked about this probability. Alan? 2/9, yeah. What about probably blue then yellow? 2/9. And the probability of yellow. Yeah. 1/9. 1/3 times 1/3. Now, I asked you guys to draw this, try to match the size. They made blue twice as wide because it was like twice the chances. Is this table perfectly designed for the size to match what we're trying to show? What would we need to modify? What would we need to change? And you can actually compare this to my table when I started erasing stuff. What's wrong with this table? Marvin? So I totally agree with you. What we need to fix this 2/3 and that 2/3 are not correctly showing what they should. This width is good. They made it wider. They made it twice as wide as the yellow because it has more of a chance. But here, the two options for blue, they did not show as twice as tall. They kept it the same height. So Edwin, even though he's smarter, he still goofed up a tiny bit. Right? Our table accurately would look like this. Here's your blue section. Here is your blue, not writing in a highlighter. Here's your blue-yellow section, your yellow-blue section. These should be the same size, right? Because we just said they're the same probability. And yellow-yellow. You don't have to copy this one. We'll do more with these. Let's talk about 78. Pet store sells a lot of pet food. I have started getting mine automatically delivered, so I don't have to go to the pet store. On a slow day at the pet store, 3 people buy cat food, 2 people buy dog food, 1 person buys food for a snake. Katie. So, if half of the customers pay cash, half pay with credit card, what's the probability of a customer buying pet food with dog food? Well, whoa, this is asking a lot. You and your partner. Yeah, we don't have time to get to the next activity. Take a moment with you and your partner to try to figure out how we could build a table to represent this. We want to split up the type of food they buy and then cash or credit. All right, so take a moment. We've got 4 minutes. Try this on your own. How many people total buy food? We got 3, 2, and 1. Yes, 6. If I like quote unquote cheat and use graph paper, then I'm gonna make my dog food section 3 wide. Graph paper's gonna make my life easy. Or no, that's cat. Why would more people buy cat food? Who likes cats? No. I'm joking. I grew up with a cat. How many people buy dog food? 2. So I make that 2 wide. Guys, again, I would use graph paper like always. And 1 person buys snake food. Now, how many people pay for a purchase? How many people paid for a purchase today?
Everybody.
So how many?
100%.
Well, so how many? 6. So as I come over here and split this, 1, 2, 3 paid cash, and 1, 2, 3 paid credit. If we're trying to make this table show the right sizes, if I connect everything. What is the area of the table? If we go 6 wide, 6 tall. 36, right? How many are contained in here? Cat and cash. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I actually made my table the size that it should be, this turns into 936, which is actually a 4. Now, like I said, we're not moving on tomorrow, so we're going to pick up this problem like in the middle of the problem. So we're just going to come back to this slide. But we're out of time, and the class coming in is already waiting in the hallway. So let's wrap. Please do your homework. Bring questions to class. We're going to need to start by filling in some of these.